Scientists have captured the surface of the Sun in an unprecedented highest ever resolution, and the images have revealed strange findings that could explain explosive solar activity and other solar phenomena. Researchers were able to look at the scorching surface of the Sun with the help of the National Science Foundation's Daniel K. Inouye telescope, which is the world's most powerful solar telescope and is located on the island of Maui in Hawaii. The images were originally taken to fine-tune and test the limits of the telescope, but when researchers looked at the results, they realized they'd photographed the Sun's bright outer shell at higher resolution than ever before. Previous observations with the telescope found the Sun's surface to be a patchwork of granular structures, each about the size of France. In those observations, as seen here, rising columns of superheated plasma can be seen showing up as bright spots at the center of each grain, epicenters for the violent release of heat from the Sun's interior to its surface. As the plasma cools, it descends back below the surface via narrow, shadowy channels between neighboring granules. But this observation is more than 6 years old, and those images picked out details as small as 30 kilometers across. The latest new images, however, are right at the limit of the telescope's capability. In the new observation, astronomers were able to see new features smaller than 20 kilometers across a magnetically active region close to a sunspot, thus revealing an unprecedented look at the Sun's complex and dynamic photosphere, the visible surface of the Sun that exists as a thin layer of atmosphere shaped by magnetic fields and currents of fluid plasma. The new observation shows whirlpool of actions with golden bands and swirling vortices, rippling across the turbulent surface of our home star that had not been seen before. Combining the detailed imagery with computer simulations helped researchers arrive at a major solar physics breakthrough, identifying the signature of small whirlpools on the Sun's surface that could directly impact life on Earth. The small, swirling whirlpools, turns out, are signatures of what scientists call Kelvin-Helmholtz instabilities. They are caused by bits of magnetized plasma moving past each other at different speeds, similar to waves that stir when a gust of wind blows over water. This sets up small disturbances in the Sun's plasma that grow into spiraling vortices that look like breaking waves. Kelvin-Helmholtz instabilities is a well-known phenomenon that guides how fluids move and has been seen in lakes and oceans and cloud formations on Earth. They have also been observed on other planets like Jupiter and Saturn, but it had never been observed on the solar surface before. These processes on the Sun's surface could also help explain the long-standing mystery of why the corona, the Sun's outer atmosphere, is millions of degrees hotter than its surface. Explosive events on the Sun, from solar flares and jets to coronal mass ejections, are powered by extreme, fluctuating magnetic fields in the star. The explosions can impact life on Earth and cause widespread disruption on Earth, taking out power grids, satellites, GPS positioning, and other communications infrastructure. The magnetic fields are generated by the movement of hot, charged plasma in the Sun, but the physics isn't fully understood. Astronomers know that magnetic field lines can twist around each other like braided hair, creating tension that is suddenly released when the tangled lines break. What is less clear to scientists is what starts the process. The swirling vortices are now a key culprit, explaining why the field lines become braided in the first place, and perhaps why the Sun's corona is heated to a few million degrees while the surface is a mere 6,000 degrees Celsius.